So we looked at the other day how to know if it was an arithmetic sequence or not. Today we're pretty much going to be told those things. But I put this is the same definition you had on the other notes. So I just bolded what the underlined words were. So a sequence in which the difference, okay, that's important, got to know how to figure out what the pieces here. Difference between any two successive terms is constant. Okay, so we can always find some sort of difference, but it's going to be constant. That's what makes it an arithmetic sequence. And the common difference is going to be important to us, and we denote it by D. Okay. So here is the formula for this, and that is, this one I think is on your note card exactly the same. But let's talk about what n is. And remember, these are little functions, right? So this is like f of n or f of x, but we call it a sub n. It's the same thing. So the n, it just represents the term number. A sub 1 would just be the first term. D is the common difference, so we've already talked about what that is. And then A sub n is a specific term value. Oh, can't spell. So it's like if we found, if I said f of x equals x squared, and then I said, all right, find f of 2, then you substitute in 2, right? Or you're looking for what the function value is when x is 2. So a sub n would be like find a sub 20. That would be the 20th term. And then 20 is your n, and you go from there. Okay, same idea there. So on the first one, we're not really finding an actual value. It just says find the common difference and the formula for the nth term of the following arithmetic sequence. Okay, so to find my common difference is just the difference between two terms. You take the second one and subtract the first one. If you subtract backwards, your sign is backwards, and it makes everything wrong. So it is -3 minus 2, and you get -5. And if I had done -8 minus -3, I should get the same thing, because that's why it's a common difference. So there's D. And then it says find the nth term. So now I substitute all that stuff into here. A sub n is equal to, what is a sub 1? 2 plus n minus 1. So it says the nth term, so n is what I'm using here. N minus 1 times d, which is -5. Easy enough? Now we just simplify this, and we're going to get that's equal to 2 plus a -5n plus 5, which means that a sub n is equal to -5n plus 7. There you go. Easy enough? All right, so we want to find the 36th term of this sequence right here. So I'm looking for a sub 36, using this right here, which is also on your little card. And so a sub 1, what is that? 10 plus n minus 1, what's n? 36. 36 minus 1 times d, which is what? We didn't find that, right? So d is 4 minus 10, which is -6. Okay. So that means this gives me 10 plus 35 times a -6. Okay? So I purposely didn't let you get calculators today, because you get a little too dependent on those, and then you're not sure how to do this stuff. And y'all don't have that crazy work all over your paper. There's different ways that you can do this. But what is -6 times 30? -180. And then -6 times 5 is -30. So the 180 plus 30 gives me 210. And it's negative, so this is equal to 10 plus a -210, or minus 210, however you want to do it. And so that means that a sub 36 is -200. You could have bumped it up to 40, right? I could have done 6 times 40 is 240, and then 6, and then I need to take 5 of those away to get back down to 35. So then 5 times 6 is 30, so 240 minus 30 Gets me down to that 210. So make sure you can reason through that. Doesn't mean that you have to do everything in your head, but you need to be able to do it quicker and easier than what some of you do. All right, so now we have a sub n equals negative 12, a sub 1 is 14, d is negative 2, and I want to find n. All right, so my formula, since we can't see it anymore, I'm going to rewrite it. I've got a sub n is equal to a sub 1 plus n minus 1 times d. All right, I know a sub n, I know a sub 1, and I know d. So n would be my only unknown, so I can just substitute in everything I know, just like I do for everything else. So a sub n is negative 12. That's equal to 14 plus, I don't know what n is, n minus 1 times d, which is a negative 2. Right? So then I'm going to go ahead and move my 14 over. So this is going to give me a negative 26 equals negative 2n plus 2. So negative 28 equals a negative 2n, and n equals 14. Easy enough? Any questions? All right. So now we're given these things, and I want to find a sub 20. Well, in order for me to find a value, I have to know a sub 1. Do I know that? No. I have to know n, which I do know for this is 20, and I have to know d, which I don't know. So I don't know a sub 1 and I don't know d, but I can figure them out if I take what I do know and substitute it in. So I'm going to take this term, and so a sub 4 is 20. That's equal to a sub 1, which I don't know, plus n, which is 4, minus 1 times d, which I don't know. Everybody with me so far? So I'm just going to make this 20 equals a sub 1 plus 3d. But I have two unknowns. If I have two variables, what do I need? What do I have to be able to get an actual value? What? It's a system of equations. I need another equation. Oh my gosh. It's a system, guys. SAT full of systems. Some of them are in disguise, but it's full of systems. But you got to recognize that. Remember, step number 1 is recognizing that you got to have, if you have two variables, you have to have two equations. So I'm going to use this other one. I can come up with another equation. A sub 13 is 65. That's equal to a sub 1, which I still don't know, plus n, which is 13, times, oh, sorry, not times, but minus 1 times d. So that means that gives me 65 is equal to a sub 1 plus 12d. Now, I have a system of equations. I have two equations. I have two variables, right? I can do substitution, elimination, or graphing, but you can't do that because you don't have a calculator. So it's really substitution or elimination right now. What do you want to do? What's the easiest one with this stuff? I mean, you can do substitution if you want, but you're going to have to solve for something, substitute in, distribute. I think elimination, way easier, right? Because I can line these up and I can have, all right, I've got 65 equals a sub 1 plus 12d. And then I can multiply all this through by a negative 1 and get negative 20 equals negative a sub 1 minus 3d. Then it's just a big old addition problem. Okay? I mean, there's nothing wrong with substitution. It's just going to be a whole lot more work. So this gives me 45 is equal to 9d. So what does d equal? 5. Okay? So d is 5. Not my final answer, but I need d, right? I also need a sub 1. So how do I find that? I substitute it back in. Does it matter which one I substitute it into? No, I could even substitute it into that one if I wanted to, but I'm not going to. That's way too many negatives. I think we'll go with this one because the number's a little bit smaller. So 20 is equal to a sub 1 plus 3 times d, which is 5. Well, 3 times 5 is 15. When I subtract that from 20, a sub 1 is also 5. It's a coincidence. Those two numbers are not always the same. We understand that, right? So now that I have all of that, my end goal is actually to find a sub 20. The 20th term, which I don't have that. So a20 equals a sub 1, which is 5, plus n, which is 20, minus 1 times d, which is 5. So this is 5 plus 19. Oops, I guess I could have substituted that in. Ah, oh goodness, I just erased a whole lot of stuff. Crap. 12D. All right, there we go. And then 19, 20 minus 1 times 5 is what I meant to do. Okay, so let's just think about this. This isn't hard. But think about what multiplication really means. Doesn't this mean I want 19 fives? Plus I want one more, so really I want 20 fives. What's 20 times 5? 100. If you actually look at what you have and think about mathematically how the numbers work together, you can cut your work down a whole lot as far as multiplying numbers and the arithmetic part of it. We good? Any questions? All right. Oh, one more thing on the front, sorry. There are different formulas and there's different ways to find your sequences, but this right here is the explicit. And we'll talk about the other one, but this is just explicit right now today. I at least wanted that labeled. We'll talk about what it means, everything later. All right. So up at the top here, just to rewrite what was on the front so we have it in front of us, we know that A sub n is equal to A1 plus n minus 1 times d. So just write that at the top of the left-hand side there. All right, so the terms between two given terms of an arithmetic sequence, not of any sequence, but of an arithmetic sequence, are called the arithmetic means of the given terms. Okay, so it has to be the one that's right in between two other terms. Those are the arithmetic means. Okay, so it says insert the arithmetic mean between -6 and 14. So if means my sequence goes like this: -6, something I don't know, 14. Right? Got to figure out what goes in there. So I have this formula up here that I can use, and I can, even though I don't know that the term that the sequence necessarily starts there, I can just think about this as a three-term sequence: a sub 1, a sub 2, a sub 3, right? And then that means that I can do a sub 2 is what I'm looking for, right? Or actually, I'm looking for the difference. I know n, I can use that 14. What I'm looking for is the common difference so I can figure out what that middle term is, right? So I know a sub 1 is -6. I'm going to use a sub 3. I know a sub 3. It is 14. That's equal to a sub 1, which is -6, plus n, since I used this 14, is 3 minus 1 times d, which I don't know. So I'm going to move the 6 over. That's going to give me 20 is equal to 2d. So what does d equal? 10. Right, so what that means here is that is my common difference. So right here, I can take that -6 and I can add 10, and whatever this term is, I add 10, and I should get to 14. So what is -6 plus 10? 4. And then 4 plus 10 is 14. Okay, so here's my inserted arithmetic mean. What does mean mean? Average. Mean means average, right? So in this, I can't spell it. In this particular case, I could have just taken the average of the two, right? I could have just said -6 plus 14 over 2. Doesn't that give me 4? When you're asked for 1, the arithmetic mean is the average. However, when you talk about the other ones, if I need to insert more than 1, you can't just take the average. Okay, but then you can check yourself what the common difference is. So if it's just 1, yeah, you could just do the old school way, you know how to average. The problem is we're going to have more than one unknown in some of them, so we have to do the rest of them this way. But that works for every single way. So now let's look at this one. It says we're going to insert 3 arithmetic means between 9 and 29. So it means I have 9, and then 3 numbers I don't know, and then 29. So this is my little sequence, and this is a sub 1, a sub 2, a sub 3, a sub 4, and a sub 5. So what I need is the common difference. I need that so that I can figure the rest of them out. So I use my last term, which is a sub 5, right? So that 29 is equal to the first term, which is 9, plus n, which is 5, because I used that 29, 5 minus 1 times d, which I don't know. move my 9 over, so I get 20 equals 4 times D. So D equals 5. So then I add 5. That's your difference when you look like this. I'm adding 5, I'm adding 5, right? When you're looking at your little sequence here. So 9 plus 5 is 14. 14 plus 5 is 19. 19 plus 5 is 24. And then 24 plus 5 is 29, so that works. There's my answer. Okay? So because I couldn't just take 29 and 9 and add them together and divide by 2. That doesn't, it's not going to give me those 3 answers. Okay? Everybody okay with all that? We good? All right. So now, all right, we're going to talk about an arithmetic series. What we just did was sequences. This is a series. So an arithmetic series, okay, is the indicated sum of the terms of an arithmetic sequence. So if you have an arithmetic sequence, you're going to get an arithmetic sum. So I put a little examples of this is a sequence, this is a series, same numbers. The sequence is just a list. Okay, 6, -6, -3. You're listing them out, whatever it is. The series is the sum of all the things in the list, or a partial sum depending on what it is that we're looking for. Okay. So I want to talk to you about Carl Gauss, and you may have talked about some of his stuff. He was a mathematician. He had a lot of great contributions to math. But if you've are any of you in statistics? Annis is, but he's sleeping, so he's not going to be able to help us out. Are you in stats? Okay. Y'all talked about a Gaussian distribution? No? Okay. So I think you all know what a Gaussian distribution is. You may not have heard those words. I thought maybe he had. You know what a bell curve is? Okay. So like I think that used to be the thing that like college professors did, where the curve for the grades was like a bell curve. So like these would be the A's, these would be the F's, these would be the C's. That's a bell curve, right? It's kind of like the old school way to do grading. But anyway, that's also called a normal curve or a Gaussian distribution. But when he was little, okay, and so there's lots of versions of this story, but he was like in 2nd grade, okay, and his teacher gave the class some busy work. Said, okay, I want y'all, you're going to sit there, you're going to add up the numbers from 1 to 100. And then she was going to go sit at her desk and maybe get some grading done or just get off her feet for a minute. But she was like, they are going to be busy for a while because this is 2nd grade, right? So she noticed real quickly that he was just sitting there like twiddling his thumbs. And so she went over there and she was like, hey, what's going on? He's like, oh, I have the answer. She's like, how did you do that? Well, because he was always looking for the easy way out, like a lot of y'all are. Then he noticed a pattern real quick, so he came up with the pattern. He had the answer. He wasn't doing the addition like everybody else is. But that's also why sometimes you want to kind of look at things and think about what could I do instead of just jumping in and doing the math all the time. But here's what he did. And in general, the idea is that if I'm going to add the numbers 1 to 100, how many numbers am I adding? 100, right? There's 100 numbers I'm adding. So as I'm adding them, there's also, there's 1, then 2, then 3, all the way to 100, right? Or n in this case. So if I look at that opposite way too, so this is 100, 99, 98, 97, blah, 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 all the way down. If you put those two things together, right? Getting larger, getting smaller, then this was your 100, but you added 1 more because that was like your last one going the other way. So this is really your n plus 1. I don't know if you can read what that says because I had to shrink it. N plus 1. And then here, this would be like your 1 to 100. This is your n. Does that make sense to you? So if I multiply n, so the sum that I'm looking for, which we do like the sum of n like this, that what he did was 100 times 101, because that was his n and his n plus 1. But is that going to be the right sum? What's the problem with just multiplying those two? How many marbles are actually in this? 200, twice as many, right? Because you got bigger and you got smaller. So once he did that, then he just had to divide it by 2, and he got his answer. Because you can kind of lay it out and look at the pattern, and bam, there you go, and he had his answer. So if you take this, and we're going to adjust it for n. The 100 was our n. So we're going to make that n over 2, right? So this is like your n. This isn't necessarily n plus 1. The reason that that ended up being n plus 1 right there is just because of the nature of what that actual pattern was. But what it is the first term and the last term added together. So this right here is a sub 1 plus a sub n. So when I put that in, I get a sub 1 plus a sub n, and there's your formula. That makes sense to you? Works for any of the arithmetic sequences. If it is a finite series, right, it has to be finite, which means it's not infinite, right? And we would have to know a sub 1 and a sub n. But there you go. There's Carl Gauss, right? We good? The answer is 50-50. I don't want to spend any time finding it, but. All right, so let's look at this here. This is what we just came up with. Now on your card, it's written differently. On your card, it has n times what's in parentheses all over 2. I'm not a big fan of formulas like that. You'll see it either way, depending on what resource you look in. But I'm not a big fan of those because then when these numbers right here end up being fractions, you have a fraction and a fraction. And even though I know you can handle that, don't you sometimes do weird things or it makes you uncomfortable? It's really better just to have it out front for all of them. I don't care which one you use, but I decided to leave it like this. It's different on the card, but do you see how it's the same thing? If I just multiplied through, it's the same thing. All right, so this is for the formula for the sum of a finite and arithmetic series, not just any of them. Right? There's two different ones here. This one right here is for when the last term is known. So I know what a sub n is. If I don't know what it is, I can find it, right? If I know that to find a sub n, that's just a1 plus n minus 1 times d, right? So if I take this, and if I don't know what a sub n is, I take this and I can substitute it in there. Now, I can do it separately and then I can substitute it in. Or if I substitute it in the formula, if this right here replaces all that, then there's a plus 1 plus a plus 1, that's where the 2 comes from, and then plus all the rest of that. So this is when you know the last term, and this is when the last term is not known. If there is a situation where you had to remember the formulas, I'm going to give these to you, but if like you had to know them, really you only have to know these two, and you just have to know how they go together, and you could always do that separately if you needed to. Okay. Everybody good so far? All right, so let's look at number 1 here. It says find the sum of the arithmetic series below. All right, so do we know the last term of this one? Yes, this is a sub 1, this is a sub n, whatever that is, right? So that means I can use this first formula. I'm looking for the sum of, I don't really even know how many numbers, right? That's equal to, I don't know n, over 2 times a sub 1, which is 3, plus a sub n, which is 99. So I don't know n. How can I find n? Any ideas? I need n to be able to finish this. Can I use that formula we've been using on the other pages? Would I know everything if I used this? A sub n equals a1 plus n minus 1 times d. All right, well, I'm looking for n. I know what the value is. It's 99. I know this. I don't know n. Can I figure out the common difference? Yes, so I can figure out everything I need where I just have one unknown. I can figure out what n is. So what is your common difference here? 3. It's just 6 minus 3. It's just 3. So the common difference is 3. So to find n, which I got to do to be able to finish this, it's going to be 99 equals the first term, which is 3, plus n, which I don't know, minus 1, times d, which is 3. So I'm going to move that 3 over. I'm going to get 96 is equal to 3n minus 3. So 99 equals 3n, and n equals 33. So now that I have that, I can come back and substitute it in these two spots. So what I'm really looking for is the sum of these 33 numbers. That's equal to 33 over 2 times, what's 3 plus 99? 102. So when I multiply a fraction by something that's not a fraction, then I can put it over 1. I'm going to rewrite it just so that my markouts and stuff don't, right? So we're going to practice these things without a calculator. I know as soon as you leave this room, you're grabbing a calculator, but I want you to actually use your brain sometimes. So can I reduce this before I multiply? Yes. I can reduce that 2 with the 102, and that gives me 51. So really all I'm doing now is the 33 times the 51. All right. So can you do 30 times 51? What's 30 times 51? 1530. If I'm multiplying 51 times 30, that's going to be 1530. What's 51 times 3 then? 153, right? And then so together that gives me 1683. So the sum of the first 33 digits is 1683. I'm going to give you the formulas. I'm not necessarily going to give you a calculator, so you need to be able to handle these things. Again, don't always have to do it in your head, but you want to do it in a simpler way than sometimes what some of you do. I think a lot of you have already kind of gotten those things figured out, but it will benefit you greatly the better you get at that. Okay, so now we're going to find the sum of the first 48 terms of the arithmetic series below. Do we know the last term? No, so we have to use that second formula up there. So I'm looking for the sum of the first 48. That's equal to n over 2, so that's going to be 48 over 2 times 2 times the first term. What's the first term? 4, right? Plus n, which is 48, minus 1 times d. What's d? 4. D equals 4. So I can go ahead and simplify this. 48 over 2 is 24 times 8 plus 47 times 4. Right? So let's do 47 times 4, and let's do it this way. What's 47 times 50? I'm sorry, we don't want to do that. What's 4 times 50? Sorry, trying to make. Yeah, 4 times 50 is 200, but I didn't want 50 of them. So I got to do that difference, which is 3 times 4, and subtract the 12. And what does that give me? 188, right? So 8 plus 188. You could also do 4 times 40, which is 1600, and then 4 times 7, which is 28. You add them together, you get 188 there as well. So it's 24 plus that. So that gives me 24, times. 24 times 196. So 24 times 200 would be what? 4,800? Is that what 24 times 200 is, right? But I need 4 of those. To multiply something by 4, to subtract 4 of those. To multiply something by 4 is easy. You double it and double it again. 2 times 24 is 48, times 2 is 96, right? So what's that going to give me? 47 what? 04. Any questions? Good? All right. So now, goodness. I want to find the sum of the first 60 terms of this sequence. So to find the sum of 60 terms, and not only do I not know the last term, I don't even know the first term. Can I find them? Yeah, I mean, it's pretty easy to find, right? So the first term means n is 1, so I'm substituting that in there. It's going to be 4 times 1 plus 1, which is 5. Okay. I need, which other term do I need? The 60th, and that'll give me the last term. So when that's 60, that's going to give me 4 times 60 plus 1. So that's 241. Now I can go substitute it in, and now I can use the first one since I know the last term. N is 60 over 2 times first term, which is 5, plus the last term, which is 241. So that can be 30 times 246. All right. What's 30 times 250? What's 3 times 25? 75. And then how many zeros do I need? 2, the 30, and then the 250. Right? But I didn't want 250 of them. There's 4 extra there. So I got to do 4 times 30, which is 120, right? So think about this when you're subtracting things too, because I know you're intelligent and you can handle things like this, but sometimes we subtract easy numbers wrong because we're not thinking. Do it even in your head, a piece at a time. 7,500 minus 100, now you're at 7,400, and then when you subtract 20 more, that's going to give you 7,380. Because sometimes when you do those in your head, you don't borrow and carry and do all that stuff right. But the sum of the first 60 terms, this right here. We good? Any questions at all? All right. So these aren't going to be bad. They're like little math puzzles. They all work out pretty decently. There's a couple of application problems on the back. They're super easy application problems, but I would read them carefully and make sure you're using the right numbers in the right places.